In this video, we're going to talk about factoring, prime numbers, and prime factorization. Now, first of all, let's look at two meanings of the word factor. So when we use the word factor as a verb, for example, factor 6, what it means is to ask us to break down 6 as a product, which means multiplication. What times what equals 6. And so, for example, we could break down 6 as 2 times 3, or we can break down as 1 times 6. So the answer is expression. It's a numeric expression. It's 2 times 3 with the multiplication symbol between them. Right here, because I only have numbers, I use the cross symbol. But if you don't like the cross symbol, you could use a dot or just use parentheses. So this is the first meaning, breakdown. And remember, the answer has a multiplication symbol between them, the whole thing together, two ones highlighted. But we can also use the word factor as a noun, which is found all factors of 6. And over here in the second case, a factor of a number is a number that can go into 6. And from the factoring process, we can see that, of course, if we can break down 6 as 2 times 3, that means 2 goes into 6, 3 goes into 6. So we have these two numbers. And also, if we can break down 6 as 1 times 6, it means 1 goes into 6 and also 6 goes into 6. Well, so the answer for the second question, find all factors, we actually have a list of numbers, and all of these numbers can go into 6. So the answer, depending on the question, and the answers will look different. And although they are kind of related, but the answers are different. So for example, factor 6, to break down 6, we have to write it as 2 times 3. The multiplication symbol must be there. But if they just ask us to find all factors, we use the comma to separate between those factors. So again, factor is smaller. It's usually smaller. It could be the largest factor is the number itself, but most of them you can see 1, 2, 3, they're smaller than 6. All right, so next we're going to talk about prime numbers. And notice in the factoring here, two different types of factorings here. I have 2 times 3, 1 times 6. And 2 and 3, they're both what we call prime numbers. So what is a prime number? But 1 is not a prime number, 6 is not a prime number. So here's the definition for prime number. It is a whole number. Whole number is like 0, 1, 2, 3, 4, and so on. And greater than 1. So which means we are going to exclude 0 and 1. So whenever we talk about prime numbers, we automatically just disregard 0 and 1. And also there has another condition here that has no factors other than itself and 1. So which means we know from the example here 6, the number 1 always, the number 1 can go into any number. So which means one of the factors of any number is always going to be 1. And also the other number is itself. So for example 6 can go into 6. So that's why any number itself is also a factor. So that's why they have to exclude these two cases. So itself and 1, because any number itself is a factor of itself, and 1 is also a factor of the number. But other than those, if it does not have any other factors, we call this number prime number. So for example, by the way, whole numbers are starting from 0 and goes on forever. But prime numbers, first of all, 0 is not a prime number, 1 is not a prime number. We exclude it, we disregard them. And we start with 2. Now 2 is prime because if we think what numbers can go into 2, only 1 and itself. There are no other numbers that can go into 2. It satisfies the condition. So Prime number, if it's a number bigger than 1, first of all. Secondly, it only has 1 and itself as factors. There are no other ones. So same thing for 3, because only 1 to 3 can go into 3, no other ones, so it's prime. And the same thing for 5, only 1 to 5 can go into 5, there are no other ones. And same for 7, 11, and so on. But notice 4 is not here. 4 is what we call, if it's not a prime, we call it composite numbers, which means other than, because if we think what numbers can go into 4, not only 1 to 4 can go in there, but also 2, because 2 can also go into 4. If we can find any factor, any number other than 1 and itself, which can also go into the number, then it's called a composite. I mean, if you think about it, because 4 can be composed of 2 and a 2. 2 times 2 is 4, and that's why we call it a composite. But prime numbers, like prime is important. So these are like the important numbers because we can use these numbers. We can use these numbers to compose all the other numbers, which are called composite numbers. Same thing for 6, as you can see. Other than 1 to 6, we also have 2 and 3, which means we can break down 6, or 6 can be composed of 2 and 3. Same for 8 and 9. 8 is we can break down as 2 times 2 times 2, and 9 can be broken down as 3 and 3, and so on. All right, so that's the definition of prime numbers. Now we can talk about something called prime factorization. So when we break down the factor 6, we just looked at the example. We could break down as 2 times 3 or 1 times 6. But remember, 1 is not a prime, and 6 is not a prime. So we're going to only take the answer 2 times 3. These are because they're both prime numbers. So a prime factorization, or usually they say factor 6 into a product. Remember, product means multiplication, means times of prime numbers. So the breakdown, and you can see here 2 times 3, 2 is prime, 3 is prime. And the product is the multiplication. So this is the answer. So we're not going to use 1 times 6 anymore because 1 is not prime and the 6 is not prime. And remember that factors, when we say found all factors, which is a number that can go into 6, if they didn't say found prime factors, and you can include 1, 2, 3, and 6. But if they say prime factors, then you can only use 2 and 3. All right, so there are some rules to help us to break down a big number. So here are some rules to help us check whether 2, 3, and 5 is a factor of a given number. So rule for 2. Now, what kind of numbers are divisible by 2? Or in the other words, 2 can go into what kind of number? And we know 2 can go into 2, 4, 6, 8, and 10, right? So all these numbers end in 0, 2, 4, 6, and 8, or 8. By the way, 2 can also go into 0. It's just the 0 times. So how do we quickly check if 2 can go into a number? So we look at the last digit, whether if it's 0, 2, 4, 6, 8, and then it's divisible. 2 can go in there. And these numbers are also called even numbers. Now, what about here's some examples. So if we see the last digit of the number is 0 or 8, okay, 2 must go in there. So for example, 2 goes into 60 30 times, and 2 goes into 138 69 times. Now let's look at the next example, rule for 5. And we know 5 goes into 5, goes into 10, and 15, and 20, and so on. So if we count by 5s, 5, 10, 15, 20, and notice all these numbers end in 0 or 5. So here's the rule. So when we look at the 60, the last digit is 0, which means 5 can go into 60, actually exactly 12 times. But if the last digit is 8, it's not a 0, it's not a 5, and the 5 cannot go into 138, which means when you try to break down 138, you're not going to say 138 equals 5 times something, because 5 cannot go in there. And next, we're going to look at rule for 5. And this is one probably not many students are familiar with. So the rule to check whether 3 goes into a number is to add all the digits. The sum means addition, all the digits. So what we do is, for example, 60. You may already know 3 can go into 60, but if you don't know, what you can do is add 6 and a 0. 6 plus 0 is 6. And 3 goes into 6. Then 3 must go into 60. So same thing for 138. If we didn't, we don't really want to do a long division or use a calculator to do 138 divided by 3. We just want to quickly check. So what we do is we add these 3 digits, 1 plus 3 plus 8, and we get 12. And we know 3 does go into 12. If 3 goes into 12, and then 3 goes into 138. So this is how we quickly check whether 3 goes into a number or not. Because when you just look at 138, you may not be able to see whether 3 goes in there. But when you add 1, 3, and 8, you get a very small number, 12. Because after we add all the digits, we only get 12. And we know 12. We can easily see 3 goes into 12. That's why 3 goes into 138. So we can during the factoring, these 3 rules are very useful. So let's see how we break down or factor 60 into a product of prime numbers. So make sure all the final numbers are prime. Make sure you have multiplication in there. So here I listed all the prime numbers for your reference. So this is what we do. You can, if you're not sure how to do it, you can always start with the smallest prime number 2. And then next check 3, and then check 5 and 7. So we're going to start, I started with 2. And we know 60 is even, and 2 does go into 60. And I just need to figure out 2 goes into 60 how many times, which is 30 times. So 2 times 30 is 60. And notice 2 is already prime. So you can leave 2 by itself, but we do need to break down 30 because 30 is not prime. So I'm going to circle 2 because 2 is already prime. But I'm going to continue to break down 30. And 30, 2 can also go into 30, so 15 times. So I can break down 30 as 2 times 15. So these 2 numbers come from 30. And notice the first 2 are prime, and we're just going to need to break down 15. And the 15 can be broken down as 3 times 5. And now this is we also have to bring down the first 2 and the second 2 we got. First 2 comes from 60, and the second 2 comes from 30. But these ones, we have to bring them down. So the final answer, 2 times 2 times 3 times 5, all of these numbers are prime. And when we multiply them, 2 times 2, 4, 4 times 3, 12, 12 times 5 does equal 60. So which means this factoring is correct. And the final answer is 2 times 2 times 3 times 5. If you have trouble doing this, you can also use what we call factoring tree to do this process. So first you will start with the number given as the root, 60, and then you break down 60 as 2 numbers. What I did over there, I used the 2 times 30. You actually don't have to start with the smallest 2. If you know 60 is 6 tenths, you can do 6 times 10. And notice 6 is not prime, look, and because 6 can be factored as 2 and 3, and 10 can be factored as 2 and 5. So you can continue to break down 6 and 10, and then we got 2 and 3 and 2 and 5. And notice they are all prime numbers. Although the order is different from here, it's the same numbers, 2, 2, 3, 5. So you will put your answer in this format, 2 times 2 times 3 times 5. So you need to, if you use the factoring tree, make sure you do one more step and to write down your answer as this, 2 times 2 times 3 times 5.